Hi, this is Mohammad Derikvand. In this video, I'm going to introduce a research that we are doing at Aalto University on deconstructible connections for timber concrete composite floors. Timber concrete floors are composed of a number of individual timber beams or a panel type engineered wood product connected to a thin concrete slab through shear connectors. These types of composite floors are commonly fabricated using permanent connectors. Permanent connectors, however, cannot be disassembled, and this can result in waste management problems and create challenges for the disposal of timber concrete floors at the end of service life. In this research, a design for disassembly approach is promoted for timber concrete floors by developing deconstructible connections. The main concept here is to establish a solution using which a self-tapping screw can directly be used as a deconstructible connector, in the same exact way as it is used in the fabrication of permanent connections, by simply driving it into the timber components and casting the concrete on top. For this purpose, the head and the upper part of the screw need to be covered by a protective layer to avoid direct exposure to the fresh concrete and enable the possibility of disassembly. Up until now, several prototypes of this connector concept have been made with different designs and material types. Some preliminary shear tests were performed on one of the early prototypes that was made of a self-tapping screw covered by a plug made of rigid PVC and inserted into a glulam element at 90-degree angle. The aim was to evaluate a scenario in which a somewhat flexible material is used as the protective layer to cover the self-tapping screw from the concrete. The key finding at that stage of the research was that the shear properties of the connections could be highly influenced by even minor changes in the design and material type of the protective layer. More details on these tests can be found in our paper in the Proceedings of the SWSD Convention. Additional experiments are currently ongoing on the shear properties of the proposed connection concept using a different design of the connector and a choice of more sophisticated materials than PVC for the protective layer. For more on this, please follow our research at Aalto University.